So in this video we are going to see Maxwell's reciprocal theorem. So we see I have drawn two cantilever beams and shown the deflection. We have 2 points A and B. We are applying load WA at point A, and in this particular problem we are getting deflection at point B as YB. Now I am giving a new same beam. I am giving a new load which is WB at the exact same point B, and I am getting some deflection at point A which is YA. So these all four values are related by load at A into deflection at YA equal to load at B and deflection at B point. So you see YA and WA are of different situations. Here we are taking applying load YA, but we are taking the here we are giving the load WA, but we are taking deflection of the other situation where we are applying load at B point, which is some different value of load. So this is the relation, and this is apply only for point load. This is called as Maxwell's reciprocal theorem. Sometimes they give WA and YB, and they also give WB, and they ask what is the deflection at YA point. So this is a direct calculation for it. So it is much useful for such problems. Now this is some generalized formulas that are easy to remember. There are short tricks that I have developed, and it is available also on uh, various sources. Maybe if you Google it, you will directly get these formulas. So if you see, if I apply pure moment, here I am applying a point load at end. Here I am applying a uniform load which is small w, Newton per meter, and here uniformly varying load where W is a maximum load. So now these four conditions, if we calculate maximum bending moment in these four categories, so here M entire length, if you will find maximum bending moment from bending moment diagram, you will get M. In this particular location, W into L will be the maximum bending moment. In this, WL square by 2. In this scenario, maximum bending moment will be WL square by 6. So you have to remember M, WL, WL square by 6, WL square by 2. Here it is small w, and here capital W, WL square by 6. Here also capital W. So these four values you can directly remember, or you directly know this is M, this is M into L. In these two cases, you remember WL square by 2, WL square by 6. Now slope value, if you see, it is ml by ei, ml by 2 ei, ml by 3 ei, ml by 4 ei. Here m value, you have to keep these four values. So simply ml by ei is wl, so you put wl into L divided by 2 ei. Here m value is wl square by 2, here m value is wl square by 6. So you directly have four value of slope: ml by ei, ml by 2 ei, ml by 3 ei, ml by 4 ei, and these four values are theta values of these conditions at the endpoints. Now to calculate deflection, you have all four theta values. So you have to multiply theta times L by 2, 2L by 3, 3L by 4, 4L by 5. And this theta you have to take from these situations. So the ml by ei for this, ml by 2 ei for this condition. So slope and deflection for particular condition are respectively. So here theta is ml by 4 ei, so like that, and this m value is this particular value. So you have to replace here m, and then theta value you have to put it here. We will get deflection for all these cases. So this is how you have to find. And if they are applying load w and uniformly distributed load in one case, so they are giving in both cases, then you simply have to add theta and add deflection, because they are all values. Let's say I am applying moment and also one particular load w, so I'm mixing these two scenario at once. So for theta you have to add these two value. So new theta for the superposition situation will be summation of these two, and for deflection also you add this deflection plus this deflection. Like this you can add or you can subtract also. Let's say this is the load that I am given, and there is a negative w load which is acting from downward. So I can subtract this theta minus this theta for that case, where this load plus the negative times W at the end is given, and deflection also, this deflection minus this case deflection. So like that we have to use all this formula. We will get many cases solved by these four formulas. And the other two cases that you have to remember, which are frequently asked: simply supported beam, you remember WL square by 16 EI, and deflection for this case is WL cube by 48 EI. So the slope is at end points and deflection is at center point. For this case also, slope will be WL cube by 24 EI at the end points, and deflection at the center point will be 5 by 384 WL raised to 4 divided by EI. So these four cases you directly remember. You see here L square, here L cube, here L cube, here L4, and 16, 48, 24, 5 by 384. Like that you can remember. But these four cases you can directly remember the trick. You don't need to remember the exit formulas, and you can derive easily. So this was it for the video. Thank you for watching this video.